data poisoning is when an adversary decides that they're going to try to disrupt your model by tampering with the integrity of your data. So they're going to modify a portion of the training data or maybe the labels of the training data, and that's going to get different behavior out of your model.
Data poisoning attacks on AI models are a growing concern in the ever-evolving landscape of artificial intelligence and cybersecurity. As AI becomes increasingly prevalent across government and industry, the need to defend against adversarial attacks has become paramount. A recent publication from researchers in the CERT division in Carnegie Mellon's University's Software Engineering Institute explores the recent trend of data poisoning in AI systems and proposes chain of custody controls as a mitigation. Welcome to the SEI Podcast Series. My name is Julie Lawler, and I am an AI security researcher in the SEI's CERT division. Today I'm joined by Dr. James Cunningham, a fellow AI security researcher, also in CERT. Today we are here to talk about data poisoning in AI systems and one possible mitigation. Welcome, James. Thanks for joining me.
Thanks so much for having me.
All right, so let's start by telling our audience about ourselves and the work that we do here at the SEI. Would you like to start?
Sure. My name's James Cunningham. I'm an associate AI security researcher here at the SEI. I've been here about a year and a half. Finished my PhD at Carnegie Mellon University in 2024, actually in mechanical engineering. Carnegie Mellon's funny because a lot of people do AI in a lot of different departments. So it was actually not as much of a transition as you might think, going from mechanical engineering to AI security. But yeah, I've been having a ton of fun in this role and excited to talk about data poisoning today.
Yeah. And then I'm Julie Lawler. I'm a researcher on the AI security team in CERT. I lead projects here researching how to secure emerging agentic AI systems. I came to CERT straight out of my bachelor's at the University of Pittsburgh, where I mainly had a background in AI and did research in responsible AI. And then what led me here was an interest in interest in responsible AI transitioned to an interest in secure and safe AI. So also not what I imagined I was going to be doing, but was a natural transition once I got here. All right. So let's begin by talking about data poisoning in AI systems. Can we start by defining data poisoning for our audience?
Sure.
What is it and how does it occur?
Sure thing. So as we both know, models are very dependent on the data they're trained on. So, if you change the data, you're going to get a model that does different things. So data poisoning is when an adversary decides that they're going to try to disrupt your model by tampering with the integrity of your data. So they're going to modify a portion of the training data or maybe the labels of the training data, and that's going to get different behavior out of your model. So there's kind of maybe two flavors of this, one that's easier to do and one that's harder to do. So you could have like an untargeted data poisoning attack where you're really just trying to degrade the data so that you also degrade the model. You're not really trying to get it to do anything in particular. It's just not going to work as well. Or you could do something very targeted where that's kind of like a backdoor attack. So I put like a trigger in your data that when your model sees it, it's going to do exactly what I want it to do. So that's like another version of data poisoning. And they're both problems, but it's kind of two different flavors of it.
Yeah. So how big of a problem is data poisoning? Beyond the incident we mentioned in the introduction, are we seeing an increase in the number of reported incidents?
So it's kind of interesting on the reported incidents front. I mean, we have things like the AI incident database, but there's not a lot of like training time attacks like data poisoning that are showing up in that. You're seeing a lot more of like the outputs of my model are wrong. And, maybe it was because of data poisoning, maybe it was because of something else, right? We've seen a lot of reports in the academic literature by, Carnegie or different things Anthropic's been putting out showing that data poisoning is possible and it has real impacts on models. So there's like a very big signal that like this is a feasible style of attack. But I think, some of the things we'll talk about is like the way that people do AI right now makes it really hard to tell, to even know how would you diagnose that my data's been poisoned, right? So I think it's probably very underreported how often data poisoning is happening.
Yeah, and I mean, with that, you say like it's hard to, sometimes you just get a model that doesn't work, mm-hmm. And there's no exact way to know if it was poisoning. Can you talk more about like why it's so hard to tell if data poisoning really occurred?
Right, so like, let's say that I just downloaded some data set off the internet, right? I trained a model on that data set. Say maybe I even downloaded the model off the data set and I fine-tuned it, right? So now we have these like sources of untrusted artifacts that I have not verified what's in this data. I have not verified this model that I downloaded, and now I'm producing something that is wrong, and I'm like, well, where did it go wrong? Also, machine learning is a little bit hard to get to work in the first place, right? Even if nobody's attacking you, right? So you might think, I need to train it better or something. And then even if you think you're being attacked, there's like a lot of different surfaces where you could be attacked. So if you think it's data poisoning and you haven't verified your data, like you need to like run a detection on all that data of like, what are anomalies that I can look for, things like that. There's different things you can do, but they're all pretty involved. And so I would believe that not a lot of people are doing very sophisticated audits of their data if they think they've been poisoned.
So what's the current landscape right now in terms of mitigating against and responding to data attacks in AI systems?
So there's some work in the academic literature on doing anomaly detection, so saying that like this data clearly is not in the distribution that all the rest of the data is. This looks like it's been tampered with. That's like one way that you could make that judgment. There's other work on robust training methods against data poisoning. You're usually making some kind of trade-off there in terms of accuracy or training time or something like that. So there's real trade-offs with trying to robustify your training against data poisoning. There's work on if your model's been poisoned, can you unlearn the poison thing that has been that your model learned? That there's some signs that might be feasible, but it's also very expensive. Like you need to know what exactly it is you're trying to unlearn. As opposed to just saying like, oh, my model's not working well, like get rid of the poison data. You know, that's harder to do. There's also governance frameworks out there like MITRE Atlas and the NIST AI risk management framework. They kind of lay out the risks of data poisoning and have some kind of, I guess a little bit more generic, I would say, mitigations of things you can do. Like control the access to your models and control access to your data, sanitize the training data. Not a lot of details on what that means maybe, but like the idea that you should be sanitizing your training data, validating your AI models. These things are kind of like, there is some guidance that like you should be thinking about these kind of things, but not a ton of very specific best practices.
Yeah. So I guess that was pretty general. Do you have any idea of, like, in practice, what specifically practitioners can do or are doing right now to actually prevent this?
So in terms of what they can do, we could talk a little bit about our colleagues' work on chain of custody with the data pipeline. I don't know if you want to transition into that here.
Yeah, so two researchers on our team, Renee Metcalf and Matthew Chirilla, recently published an SEI blog post advocating that preventing data poisoning is more important than ever. In their post, they propose a proactive approach with chain of custody controls. So let's explain for our audience what chain of custody controls are and how they work.
Yeah, so the basic idea is that if you have an artifact, what you want is an unbroken record of everybody who possessed that artifact and when they had it and what they did to it. And so we do this actually with cryptography in the cybersecurity world. So the kind of different cryptographic mechanisms we use are one, we compute hashes of files. And what that basically is that says a given file will have a specific hash. And if you change that file, it's going to have a different hash. So if you hash it at a certain time, you can say that like, this is the file that I'm expecting. And if it has this hash, if it doesn't have this hash, then it's not that same file. So that's a way you can check for integrity of your data. The second mechanism is digital signatures. So that gives us authentication and non-repudiation. So that basically means that you have an identity tied to a specific entity, whether that's a person, it could be like a device, and that they sign that file to say that like, I am asserting that I saw this file with this hash at this time, right? And so they can't deny that they made that attestment, and it is tied specifically to their identity. And then the final piece is just something simple, append only logs. So you can't actually erase the logs that have exist and change something that already happened. All you can do is append to the end of the log. So it's this record that you can't retroactively change the past. You can only update that I've done something to it, in the present. So combining all those things, it gives us a way to say cryptographically that like we've tracked every single thing that's been done to this artifact. In the case of AI, it would be like our data that when it came off the sensor, we signed it, we computed the hash of it, and then every time somebody manipulates it in any way in the machine learning pipeline, they have to hash what they produced and sign that they attest that that is the right hash.
Are you able to walk through like a toy example of what that looks like in practice?
Yeah, sure. So in the blog post, the example that it's used is a drone. So it's a good example of where you can implement this chain of custody idea, because you can imagine that you would control the entire pipeline of creating the model, from like when you're collecting data off the drone to when you're actually training the model. So like the first step would be, say that you're training an image classifier that's going to sit on this drone, and when it sees something on the camera, it's going to say, draw a bounding box around different types of objects. So you're going to get the image off the camera, and so the first thing you can do is you can say, well, my camera is going to have a signing key, and it's going to hash the image that comes in, and then it's going to sign that camera verifies that that's the image that actually came immediately as soon as it takes the picture. And then once it takes a bunch of pictures, you have all these hashes, you have all these signatures, then you're going to have a data engineer who's going to collate that into a data set, right? So your data set is the object that's going to be actually used to train the model. That involves a little bit of maybe cleaning or pre-processing, different types of things. So you're going to wind up with manipulated files, but whatever engineer did that is going to have to sign it, compute the hashes, all the same things. So you're kind of building this chain of custody, this tracking of every stage at which the artifacts are manipulated. And then after you have your data set, you train your model on it. Whatever engineer is in charge of training the model is going to, when they load in the data, they're going to verify, okay, all this data matches the chain of custody that I'm seeing. Everybody's signed off, and these are the right hashes, so I can trust that all of this hasn't been tampered with. And then you train your model after doing that check, and then finally you have your trained model. You can hash that, and you can sign that, and from start to finish, we can say that we've done something to verify that the integrity of all the artifacts that go into training the model, we have some basis to say that that's valid.
Yeah. So before, where you aren't able to say whether the model or the data set, where that came from, now you have authority to say these images were generated by this drone and they were curated by this data engineer. Yeah. Okay, so for organizational leaders who are building their first machine learning pipelines, where should they strategically implement this? Should this be in places such as data generation, curation, or model training?
I mean, the answer is yes to all of them, but I'll kind of go through and maybe like impact to cost. If you're thinking about how can I start to take some of these ideas and apply them to my process, like you would want to start with the highest impact things that are the cheapest to do. So I think probably the number one thing on that scale would be a data set manifest. So maybe you don't have 100% control, or you don't have your key signing set up for the actual data collection, so you can't do that part. What you can do is you can say, once I have all my data together and somebody's looked at it and somebody thinks, okay, this is like a reasonable data set, have that engineer sign it and compute hashes of everything and say that I, the engineer at this time, assembled this data set, and this is the hashes of everything in it. So at the very least, maybe you don't 100% trust everything coming in, but once you've looked at it and once you've done some kind of sanity checks on it, you can say, in the future, if it's been manipulated, then you would know. So whenever you train a model on it. So that's probably the biggest bang for buck thing you could do. And then after that, I think you would get into like the data ingestion boundary of like, can I set up signing of and hashing of things as soon as they get collected? If you actually have control over that, or if you're contracting with somebody, maybe you can negotiate them to set that up. That's really takes the trust boundary all the way out to data collection, which is really nice. And then if you're annotating your own data, having each annotator have a signing key associated with them, that non-repudiation is nice. So this kind of deals with like an insider threat angle of like, if a data annotator that is poisoning your data and you find out later, you can attribute that to a specific annotator if they're digitally signing all their annotations. So yeah, I think once that chain of custody has been implemented all the way throughout your pipeline, then signing your model at the end of it is like that kind of final verification of like, everything upstream of the model has been verified.
Okay. And then what about for folks who might be using open source models or aren't training their own models?
Yeah, that definitely introduces some more challenges. So it might not always be feasible to extend the boundary of trust all the way out to where your data is coming in. Say you're training on the open internet or something. Like, sometimes URLs change what's on them, and that's not malicious. That just happens, right? And you're not going to be able to get digital signatures for everything everybody posts on the internet. So like, that's fine. You might just need to do some checks after you get your data in, of like maybe look to some of that literature on anomaly detection and things like that, and just have some kind of process to, when you assemble your data set, checking for malicious things. And then you can, from that point, once you control it, once you have the data set, you can do the chain of custody from that point on.
Great. So a core tenet of our work as SEI researchers is transitioning our work. If I'm a program manager or leading a technical team, what resources can I access to begin implementing zero trust principles?
Yeah, so I'd say from like a zero trust perspective, a lot of this is relevant to what we've been talking about. So the principle of zero trust is, never trust, always verify, right? So translating this to kind of the data pipeline, we have identity for every actor. Every device, every sensor, every annotator is going to get a unique identity. The principle of least privilege, annotators only see what they actually have to see. We're continuously verifying at every stage that the integrity of what we're looking at. And so, yeah, I think there's not a ton of, unfortunately, guidance on AI-specific zero trust. But I think if you want to get kind of started in understanding zero trust, there's a few good resources like the NIST SP 800-207. That's called Zero Trust Architecture. So it's a nice on-ramp to zero trust in general. And then there's CISA's Zero Trust Maturity Model 2.0. That can help you assess where your organization is right now, and you can kind of figure out where you're at and what you might need to do next. And then for more of an AI focus, I'd recommend a couple more works by some of our colleagues. So there's The Challenge of Adversarial Machine Learning by Matt Tarilla, also author of the Chain of Custody paper, and Nathan Vadhodnis. They kind of lay out the threat taxonomy of what an adversary might make a model try to do. So like they either want it to learn the wrong thing, do the wrong thing, reveal the wrong thing. So, and then that kind of tells you, what do I need to be worried about from an AI perspective and the threat models. And then the white paper AI Hygiene starts with models and data loaders by also Matt Tarilla and others. This is an overview of kind of how AI is done today and what are the gaps in terms of zero trust principles and security that exist right now. So that kind of takes the threat model that is laid out in the first work that I mentioned and kind of says, well, where in the actual AI practice are the gaps and what can you do about it? So it's kind of related to the chain of custody thing. I would say the chain of custody is solving a particular problem in the AI security space, whereas the AI hygiene white paper is kind of laying out not just that particular failure mode of data poisoning, but all the other kind of places where the way AI is done today is kind of assuming levels of trust that probably shouldn't be assumed.
Yeah. Right. So in the post, we invite potential collaborators to send an email to info@sei.cmu.edu. Who specifically are you looking to collaborate with, and what would a collaboration look like?
Yeah, so I think we want to collaborate with anybody who is doing AI in safety critical ways, whether you're in industry, academia, or the government. We would love to have a conversation about potential collaborations. Our mission is to just kind of make AI safer and security for everybody. We want to kind of raise the level of practice that's kind of going on in the community at large. So if you feel that you would be able to benefit from talking to the experts here at the SEI in making your AI pipeline more secure, we'd be happy to have that conversation.
Great. All right, James, thank you so much for joining me today to talk about this important topic. We will include links in the transcript to resources mentioned during this podcast, including our blog post. Finally, a reminder to our audience that our podcasts are available on SoundCloud, Spotify, Apple Podcasts, and as well as the SEI's YouTube channel. If you like what you see and hear today, give us a thumbs up. Thanks again for joining us.